We're going to talk about extrema on a function and finding the extrema, which is a fancy word for the highest and lowest value. So in this case, I gave you a real life example of temperature. Although like most algebraic models, it's impossible for it to model the temperature of a particular situation everywhere, because as soon as you get to a million for time or 10,000 for time, we're going to get a very, very, very high temperature, probably unreachable on the planet. So we know we have to limit our domain, and most of the examples we have here will have a limited domain. So we're only looking for the highest temperature or the lowest temperature over a specific domain. So in this example here, we have F being the temperature, okay, and that's in degrees Celsius here, so that's F. And T, we have T being the time in hours, okay? And sometimes people get upset about or confused about negative hours, right? So what I'm going to do instead is I'm going to call this 12 noon, okay? Meaning hour 0 is 12 noon. So now when we come over to an interval like I have over here, if 0 is 12 noon, what do you think that is? Okay. It's 11 a.m. to 4 p.m., right? 11 a.m. to 4 p.m. Okay, so you can have negative times as long as it's a relative to something like 12 noon, for example. All right, so this is pretty easy. I made a table of values over here. I made a table of values. Here's my t values. Here is my f values over here. Okay, made a table of values. So you don't need calculus to solve this problem at all. Let's take a look at each one. Okay, what are the extrema, which all that means is what are the y values, or in this case f values, or in this case the temperature, what are the highest and lowest temperature on this interval, okay? Well, if you look at our table alone, we'll look at the graph too, but if you just look at the table, we have the highest value happens here and here, okay? And the lowest value happens here. So that's our first point here. You can have two extrema, right? You can have you can have three extrema here or more. You can have two maximums and you can have one minimum, or you could have three minimums and one maximum, okay? As long as it's greater than or equal to all the other values. So 18 is greater than or equal to 18, and 18 is greater than or equal to 18. So we actually get two extrema for maximums and one for minimum, okay? But I'm actually not around my interval, so let me take my green lines here, and we're going to block off this graph from -1 to 4. Okay, so I'm going to do it on the graph first. See, so it has to be between these green lines, and I'm also going to do that here. So between -1 and 4. Okay, what does that mean? That means we ignore all of this, right? We ignore this, and we ignore anything to the left of it also. So we're going to ignore over there. And if we ignore that, and we look, now there's one lowest value. This is the lowest, right? Or we actually should use the proper terminology. We're going to use minimum. So this is the minimum. It's the absolute minimum value. And this is the absolute maximum value. Okay? So all we're going to do is write, the answer is f of 2 for my min. Okay? And f of 4, which is equal to 18 for my max, okay, for my max. And that's the answer. So there's two extrema. You go ahead and do 2 and 3 and 4, although I didn't label this as 4, so let's label this 4. Try 2, 3, and 4 right now. It should be pretty easy. You don't need calculus. Just try to find the absolute maximum, highest temperature, and lowest temperature, absolute minimum for these three. Go ahead. Okay, let's find the max and min. So you hopefully moved these here to -1 on the left and to 3, okay? Notice I lost these two 18s here, right? They're no longer there because we're only looking from -1 to 13. So on the graph, -1 to 13 would be from here, I already got it marked there, to here, -1 to 3, right? So now I'm only looking at this part of the graph from -1, it's kind of sloppy, but there, to 3, right? So if you notice, and this is where we're trying to get to here, the endpoints And any peaks or valleys, right? That's really important. These endpoints, these are the endpoints, and these peaks or valleys are the only ones that really have to be considered. Nothing in between here has to be considered because I know that this endpoint's going to be higher than this, at least these parts. It's not higher than the other part over here. And nothing over here needs to be considered because I know this point is higher than all of those points, and this point is lower than all of those points on both sides. So the beauty here is I don't have to check everything, and I don't need to have a table here of every single value. I just need to check the endpoints, that's this and this, and anywhere where we have this bottom, see, where we have a valley. Of course, it also the same thing, I have to check anywhere we have a peak, which is over here at -2. Okay, so that's what I really care about, the peaks and the valleys. And there's a way to find them with calculus, which makes our job a lot easier. By the way, here is the valley, right? So this is the endpoint, this is the endpoint, and this is the valley, right? Or really, it's what we call relative min, all right? So the highest of all of these is 13, so that makes f of -1. That makes that the max, okay? And for the min, f of 2 is the min. All right, I'm gonna jump down to 4. Let's see, -2 to 1, -2 to 1, hopefully you got the max was 18, f of -2 is 18, and the minimum was f of 1, right? So it was here and here, right? So in this case, it was both the endpoints. So in this case, both the endpoints. But let's go over this one. So -2, 4. Let's go to number 4. So -2, 4. -2, 4. So if I go to -2, 4, okay, there's a problem here, right? Which is this. And that is open, right? Open. So if I was to put that here, that would be an open dot here, not a closed dot, okay? So in this, the answer is -2 for the maximum and 2 for the minimum, like we've been getting. But this is no longer, right? This is no longer no max. And that's kind of weird, but because it's open, it doesn't count. And the reason for that is if I asked you what that number is, right? You couldn't give me a number. You'd say it's close to 18, so you might say 17.9, right? So you might say, this is a max, okay? Of course, it wouldn't be because of this one. But even if this guy was not here, so even if I change this interval, which I probably should do, so it makes it an even better example. Let's change this to be -1, okay? If it's -1, then we actually have no maximum because you can't have an open interval be the highest value because 17.9 is not the answer, nor is 17.99, nor is 17.9999, nor is 17.999999. See, you can't give me an exact value because you'll go on forever, right? No exact value. Okay, so this problem, we're going to do more of this in the next slide. This problem has no minimum. Okay, so what I want to do is I want to do this problem with calculus. And I want to say to you that we don't have a graph, right? So I want to pretend I don't have a graph here. And I don't even have a table, right? I'm not going to cover up the table, but you can get the idea here. So we don't have a graph and we don't have a table. So how would I do this problem? Okay, so maybe I'll cover it up in the box. Okay, and we'll do, I think we'll do the first one again. We'll do the first one again, which we already know the answer for, okay? Well, if you remember that we had to check the endpoints, right? So we have to check the endpoints. All right, we have to check the endpoints. That's easy enough. But then the other point that we want to check is called a critical point. I may have mentioned this briefly, but we're going to talk about it again. A critical point, okay? And a critical point is when the slope is 0, okay? The slope equals 0. It's also or undefined. We'll talk about that in another example. Okay, so I'm actually going to show this again because I just want to talk about that really quick. Let's look at the slopes. So what I want to do is I want to know what is the slope here. And the slope is, of course, the slope of the tangent line. So if you draw a tangent line here, you'd say, wow, that's really steep. That's a terrible tangent line, by the way. You'd say, if I drew a tangent line like this, you'd say, wow, that's really steep. It's a very high number. But it's positive, right? It's up and to the right. So the slope here is positive. The slope here is positive, but it's a little less, right? It's a little less. It may be 4 instead of 8 or something. And the slope here is about 1, but it's still positive. And the slope here is maybe a fraction, but it's still positive. But right here, right, if we draw the tangent line right there, the slope is 0. See? And the same thing happens down here. So the slope is 0, and we'll talk about undefined in a minute, but the slope is 0 at least every time you hit one of these valleys or these peaks. So the only thing we need to do is to test critical points and to test the endpoints, right? So we're going to test -1 and 4. So I'm going to find f of -1. Okay, I'm going to find f of 4. And I have to always do those because those are the endpoints, right? We always have to check the endpoints. Okay, and I think we already know we're going to cheat a little bit and look right here. We already know the answers, right? So it's 13 and 18, right? 13 and 18, okay? So 13 and 18. But we don't know, if we try to cover this up again like I just did, we don't know what the graph looks like. So I don't know where those points are, okay? I don't know where these points are. So where does this happen? Well, we just said the slope is 0. So what we're going to do is we're going to find the slope. And the slope, of course, is the derivative. Okay? So let's find the derivative of our original function up here. Let's take the derivative really quick. Power rule. 3t squared minus 12. Okay? And we're going to set it equal to 0 and factor it. Why? Because critical points happen when the slope is 0. See? And we're going to GCF at 3, which is t squared minus 4. Divide both sides by 3. Factor this if you want. T minus 2, t plus 2. Okay? And what you're saying is when t equals positive 2 first, we'll say, and t equals -2 here. When both of those things happen, those are critical points, meaning it could be a valley or a peak, and we have to check those too. Now, the only reason I don't have to check -2, right, I'm going to throw that one away. And let's just cheat a little bit with f of 2. So f of 2 was -14, of course. So f of 2 is -14. What would you do? Of course, you just plug it into our equation here, right? Just plug it in here and get a value. But notice I'm going to throw away this value, right? I'm going to throw away this value. I'm throwing away that value because it's not between -1 and 4. It's to the left of -1, see? So I don't always have to test every critical point, only the critical points that fall in between our endpoints. Okay, so once I've done that, this isn't really an endpoint, so let's do that. These are the endpoints, right? Okay, and this is the critical point. Okay, so once I test them, I just look at the numbers. What is the highest number here? That's the max. What's the lowest number? This is the min. And this endpoint we ignore, right? So this endpoint, this first endpoint here has no bearing on the problem now that we've tested it. And all we have is a max and a min. And it's that easy. All right, we'll try an example like that right now. So let's go to the third page here, okay? So I want you to find the extrema over the closed interval -1 to 2. There's no tricks here, so there's no open interval here. So -1 to 2. I want you to find the extrema. And the way you're going to do that is you're going to check the endpoints. And then you're going to check the critical points. Well, you're going to find the critical points. So let's say find critical points. Right? And that's, of course, f prime of t equals 0. Right? I said f prime of t equals 0. And then you're going to test the critical points. Test our CPs. And 4, we're going to find which one's the max and min, right? Determine which one is the max and min. And remember, we could have more than one. Okay, so go ahead and do that. Pause the video, go through these 4 steps, and see what you come up with, and then I'll solve it for you. Okay, so first thing I'm going to do is test the endpoints. Okay, -1 to the 4th is +1, so that's 3 minus 4 times -1, so that's 3 plus 4 is 7. And then we're going to plug in 2, so 2 to the 4th, 16 times 3 is 48. And then 32 minus 32 is 16. Okay, but there might be some critical points, right? There might be some critical points, right? There might be some other ones we have to check. I don't know. How are we going to find that? We're going to take this and we're going to take the derivative. So we're going to set f prime of x equal to 0, okay? And the derivative is 12x cubed minus 12x squared, okay? And we're going to GCF, so 0 equals 12x squared. And that's x minus 1. So my 2 critical points are x equals 0 and x equals 1. So I need to check those. So I'm going to check f of 0 and f of 1. If I'd only had 1 critical point, I would only check 1. Both of these, by the way, we've got to be careful about that. Both of these fall in this domain, right? From -1 to 2. So 0 is in there, and so is 1. So we have to check both. In the previous problem, we didn't have to check both. Okay, f of 0 is 0. And f of 1 is 3 minus 4 is -1. All right, and then the last step. So what is the max and what is the min, right? So the highest of these 4 numbers, this is the max. And the lowest is -1, so this is the min. Okay, it's that easy. You don't need a graph. The whole key is between -1 and 2, these numbers are going up. And from 2 to 0, these numbers are going down. And also to 1, it keeps going down. So this ends up actually not being like a peak or a valley. So we'll take a look at that maybe when we graph it in class tomorrow. All right. Let's go to the slide and let's just draw a couple of examples that might trick you up a little bit, right? So I'm going to have some that are not closed intervals here, and I'm going to have some also that jump a little bit, right? So I'm going to do that like this. And I'm going to put a hole here and put the actual value here, and then have this go up maybe like this. Okay. All right. So see if you can tell what is the max and what is the min here. Now I'm going to make this like, you know, make up a point here. I'll make this 7, and we'll make this 3. We'll make this maybe -2, maybe 4, right? Okay. All right, so in this problem, right, there is a maximum value. That is definitely the highest value there is. This is not the maximum, right? And it's also not the lowest. So we have a maximum at 3.7, right? It's really 7 is the max, right? But I'm just writing the points here. And what about our min? Do we have a min? And the answer is no, because this value is not lower than all the other values. And these values here, as you get closer and closer and closer, you can't pick the smallest number. You can't write the smallest number. Okay, let's say this was, for example, -1 on the y-axis here, right? So the lowest you could write, you can't write -1 because it's a hole, right? This is a hole. You can't write -1. You could write -0.999 or -0.99999, but you can never write a number that is absolutely the lowest number. And so we say there's no minimum. All right, here's another interesting one. Okay, I'm not going to plot points this time. I'm just going to talk about them. Okay, And this is a closed interval, so we're okay here. We don't have to worry about this open interval, or we don't have to worry about the holes, I should say. So see, if it's not continuous, right? This is the problem, it's not continuous. This is continuous, so we know we're gonna have, okay, and that's another theory that we'll talk about in class. So this is continuous. So it's continuous and closed, so it has to have a max and a min, right? It must have a max and a min. But this guy was not, right? He was not continuous, not continuous, not continuous. So all bets are off, whether it has a max or min. Okay, but this guy does. Now, just to talk about this again, this is an endpoint, this is an endpoint, and this is a critical point. This is a CP. We have to check all three, okay? And if these were the same height here, right, we would have two maxes. I'm not going to write the point because I just made these up, but these would both be maximums, and we'd actually have one minimum. Even though, right, even though, we'll call this F, right, we'll call this F, even though F prime of, okay, I said I was going to make up a number, let's make this 2. F prime of 2 equals undefined. That's right, see, critical points being undefined. So in an absolute value function, the derivative may be undefined, and that could still be a minimum, which it is. This is a minimum, okay? So that's why we set the derivative, the first derivative, to 0, but we also set it to undefined. So for absolute value functions, or also for like rational functions, we'd set the denominator equal to 0, and we have to look at that to see if that's the case. All right, let me draw one more here. Let's draw one that looks like this, comes down here, and looks like this. Okay, can you guess? Here's our critical point, by the way. That's our critical point. So we test the endpoints. We get nothing from the endpoints. They can't be the highest or lowest value because they're open. And this is closed, right? It's a solid dot there. There's no jump there. So this is actually a minimum. So we get no max, it says no max, and 1 min. Okay, we'll do the rest of these in class, but that should give you a head start.